Alright, so 3.2, solving absolute value equations. So we're going to solve them with one solution, no solution, or two. So the absolute value of a number written as the absolute value of 6. So these two vertical lines means the absolute value is the distance a number is from 0. So what that means, we're talking about 6, then where would you find, what number would be 6 places from 0? So obviously 1, 2, 3, 4, 5, 6. So 6 would be 6 places from 0. And also 1, 2, 3, 4, 5, 6. Negative 6 would be 6 places from 0. So when you think about this, we're talking about the distance from 0. There's going to always be two answers. So with this example, the absolute value of 6 is going to be positive 6 because it's the distance from 0. And the absolute value of negative 6, again, is also 6 because it's the distance from 0. How far is negative 6 from 0? How far is positive 6 from 0? So what we know so far is that the absolute value of a number is always positive since it is a measurement of distance. Now this definition of an absolute value equation, if you remember back to Algebra 2, this is a piecewise function. So what that means, when x is greater than or equal to 0, so if I draw this out, when x is greater than or equal to 0, what we have is y equals x. So that's that line here, and all we're looking at is this part of it here. That's where you get that line up to the right. This one, when you're looking at for when it's less than 0, so this side now, then we're going to have this y equals negative x, and that's this dashed line here, which would actually only be, it would stop right here at 0, because it's just less than 0, and that's how you get that V shape that we're so used to graphing. Okay, so when solving them, these equations, there's two cases to consider. So the first one is when the expression inside the absolute value originally was positive, and when again the expression was inside the absolute value was actually originally negative. Because if it's positive, we do the absolute value, we get our answer. If it's negative, we do the absolute value, we should get the same answer. Okay, so this problem here, we're going to solve and then graph this 10 times the absolute value of negative 7 minus 2x plus 4 equals 114. So first thing that we want to do is our job is to isolate the absolute value stuff first before we do anything else. So we're going to subtract 4 from both sides. When we do that, we're left with 110 on that right side. And then from there, we need to get rid of this 10, so we're going to divide both sides by 10. And that gets us the absolute value of negative 7 minus 2x equals 11. And this is going to be our problem now that we're going to work on solving. And we're going to set it up as the positive case and the negative case. So it says the stuff inside the absolute value is positive. So what I do there is just leave it as it is, negative 7 minus 2x. I just remove the absolute value and set it equal to 11. When it's saying that it's negative, what this means is this actual part inside here is actually negative. So what again that means is actually all the numbers or all the signs were changed. So what we actually had was 7 plus 2x, so these signs changed. This one over here stayed the same. So we're going to go ahead and solve this. We're going to add 7 to both sides. And that leaves us with negative 2x equals 18. Divide both sides by negative 2, and we get negative 9. X equals negative 9. On this right side, we're going to subtract 7 from both sides. And we get 2x equals 4 and x equals 2. So we have x equals negative 9 and x equals 2. And that's all you have to do in terms of graphing. Let's do this next one. Solve and then check. Okay, so here we'd solve and graph, here we have solve and check. So we've got to isolate, isolate this absolute value right here. We'll get this on its own first. The best thing we want to do is get rid of this 8. We're going to subtract it from both sides. That leaves us with 2 times the absolute value of 9n minus 6. And that equals 78. And we want to get rid of the 2, so we want to divide both sides by 2. And that gives us the absolute value of 9n minus 6 equals 39. And that is what we're actually now going to solve. So isolate the absolute value first and then set up the two cases. First case, we have 9n minus 6 equals 39. Let's go ahead and solve that. We're going to add the 6 over, and that gets us 45, and divide both sides by 9, and that gives us 5. So we think n equals 5. Now the negative case is that everything inside was negative, so that means we have to change this whole thing, or this thing here, and make it negative. So it would be negative 9n plus 6 equals 39. So negative 9n, we're going to subtract the 6 over, equals 33. We'll divide both sides by negative 9. So that gives us negative 33 over 9. Or negative 3 and 2/3. 3 times, hold on, that would be 6. Yes, 3 and 2/3, because it would be 3 and 6/9. 9 times 3 is 27, plus 6 is 33, and then we just simplify that. So this is fine, leaving it as negative 33 over 9. The checking part, we just put it back into the original. So we have 8 plus 2 times the absolute value of 9 times whatever we think our answer is, minus 6, and that hopefully equals 86. We have 8. Oops, let's put that in there. We think that it's 5. Plus 2 times, that's going to be 45 minus 6, which is 39. We're hoping that equals 86. 8 plus, the absolute value of 39 is 39 times 2 is 78. When we add those together, we do get 86. We're going to keep this as negative 33 over 9, just to make it a little bit easier for us to solve. The second one is going to be 8 plus 2 times 9 times our negative 33 over 9, which we'll come back to in a second, minus 6, and we're hoping that equals 86. That was negative 39 over 9. I'm leaving it in an improper fraction because this becomes over 1 and it cancels out. We get 8 plus 2 times the absolute value of negative 33 minus 6. 8 plus 2 times the absolute value of negative 39. And that's 8 plus, this is positive 39 times 2 is 78, plus 8 is 86. So both of these answers are correct. And we'll talk more about extraneous solutions next class period. And what that means is answers that you think are true but don't actually work. Okay, let's do another one. Again, our job is to isolate this absolute value right here. So we want to get rid of this 4 first, so we subtract it from both sides. So we get negative 6 times the absolute value of 9y minus 10 equals negative 102. We're then going to divide both sides by negative 6. And we get left with the absolute value of 9y minus 10 equals 17. From here, our positive case is 9y minus 10 equals 17. Move over to 10. 9y equals 27. Divide both sides by 9. Excuse me, y equals 3. The negative case, remember the expression inside here was negative. So negative 9y plus 10 equals 7. Negative 9y equals negative 17, I'm sorry, positive 7. And then divide both sides by negative 9, we get negative 7/9. And then checking this, we'll put it back into original. 4 minus 6 times 9, that's a value of 9 times whatever our potential answer is, minus 10, hopefully equals negative 98. And your other one is going to be 4 minus 6 times the absolute value of 9 times what we think our potential answer is, minus 10, hopefully equals negative 98. And we're going to test 3, and we're going to test negative 7/9. 4 minus 6, and then inside here we get 27 minus 10. 4 minus 6, 27 minus 10 is 17. 4 minus 6 times 17, so that's the value of 17 is 17. times 6 is 102. Subtract that, you get negative 98. So this is one of the answers. Let's check if the other one works too. 4 minus 6 times this. Now don't let this freak you out. Cancel. You get negative 7 minus 10. Hopefully that equals negative 98. 4 times negative 6, and that's going to be negative 17 in there. Absolute value of negative 17 is positive 17 times negative 6 becomes 4 minus 102. It looks the exact same as the last one. And therefore, negative 7 ninths is also an answer. Okay, one more of these ones. So this one is a little bit different. Notice that they've got an x over here. So we're going to add 1 to both sides because I want to isolate the absolute value. And we have the absolute value of x minus 5 equals 3x plus 7. So now this time, we're going to just write it out. X minus 5 equals 3x plus 7, and we're just going to solve. Move this over, we get negative 2x equals, move the 5 over, we're going to add that, it gives me 12. Divide both sides by negative 2, you get negative 6, so that's hopefully a potential answer. The negative case, remember that means everything in here was negative, so or just the opposite sign. Negative x plus 5 equals, and the right side stays the same. Pull this over, we get negative 4x, subtract the 5 over, equals 2. Now divide both sides by negative 4, and x equals negative 1/2. These are potential answers, we want to check this. So back to the original, absolute value of x minus, absolute value of something minus 5 minus 1, hopefully equals 3 times something plus 6. And we're putting in negative 6. So that gives me negative 6 minus 5 is negative 11 minus 1. That's negative 18 plus 6. This is going to be positive 11 minus 1, which is 10. And negative 18 plus 6 is negative 12, so this one doesn't work. So that's not a solution. These are what's known as extraneous solutions. We'll talk more about why that's happening next class period, like I said. We'll do it graphically. On this right side, change colour. So we're going to check the absolute value of negative 1/2 minus 5 minus 1. Hopefully that's going to equal 3 times the absolute value, 3 times negative 1/2 plus 6. So here we have negative 1/2, so it's negative 5.5 minus 1. And then we have negative 3.5 plus 6. So this becomes 5.5 minus 1, which is 4.5. And here, this is 3.5, or 3/2 is negative 1.5 plus 6. So 6 minus 1 is 5, minus 1/2 is 4.5. So this one actually works. And that is our only solution on this problem. That's when we have one solution. Okay, a couple more problems here. So this one here would get 5 times absolute value of 10x minus 9 plus 7 equals 1. So here, just for a moment, let's think about this graphically. Now, you don't necessarily understand how to get your h from here, but you should hopefully see that there's a movement to the right. So if I was to graph this, I go right, and then my k value, so my h is in here, and my k value is up 6. So it's going to be right, and then up. So it's going to be here someplace. This is a positive 5, so your v is going to be here. This is equal to 1, which should be right here. This is not crossing. So what this means, graphically, is there should be no solution. And what happens algebraically, if we move the 7 over, subtract 7 from both sides, what we end up getting is equal to negative 6, divide both sides by 5, with an absolute value of 10x minus 9, equaling a negative number. Since it equals a negative number, an absolute value cannot equal a negative number. So this is the no solution problem. Last one had one solution, this one has no solutions. And just for fun, we're throwing in one of these crazy ones with letters. and it's going to be solved or set up the same way. So we're going to move over this negative e first. We're going to add e to both sides. And we're going to have our positive case, so negative x minus cd equals a plus e, so just as is. And then our negative case, which is going to just change all the signs, it's going to be x plus cd equals a plus e. And we're just going to solve for x. So we're going to add this over. And then we're going to divide everything by negative 1. So x equals negative a minus b minus cd. And here all we have to do is move over the CD, we're going to subtract it, so a plus e minus cd. And these are our crazy two answers. Okay, now the whole point of absolute value, or one application of absolute value, is going to be margin of error. We have to understand how to set this up. So let's go back to this part right here. It says write a basic open sentence involving absolute value for the graph. So the following absolute value equation is the graph below. So we've got x minus 4, so absolute value of that equals 8. So notice that we have an answer at negative 4 and we have an answer at positive 12. Now if you look at this to find the middle of this is 4, because that's 1, 2, 3, 4, 1, 2, 3, 4. If I said the absolute value of 8, that would just be at positive 8 and negative 8, the distance from 0, okay? This is the distance from 4. That distance from 4 is 2, 4, 6, 8. This distance from 4 to the left is 2, 4, 6, 8. So it's a distance of 8. So to simplify this in terms of helping us write it, this is our distance and this is our middle value. Okay, so let's use this to help us write an absolute value equation from these two numbers. Okay, first thing first, find the middle of the graph. The middle of the graph is 6. So what that means, I'm going to write x minus 6. Absolute value of x minus 6. And this right side is going to equal the distance. So the distance is 1, 2, 3 to the right and 1, 2, 3 to the left. So the absolute value of x minus 6 equals 3 is this problem. So that's all we're looking for. If you wanted to solve that, you would set this one, and negative x plus 6 equals 3, x equals 9, negative x equals negative 3, x equals 3, 3, 9, boom, boom. This one here, the middle, is 1, so it becomes absolute value of x minus 1 equals the distance is 2, and that equals 2. And that's it. If you set it up to solve, x minus 1 equals 2, x equals 3, boom. Negative x plus 1 equals 2, negative x equals 1, x equals negative 1. Boom, 2 answers. Alright, last example. So we're talking about an example of absolute value being margin of error. So margin of error is usually associated with opinion polls, and the most basic of terms is the estimation of how much the percentage would vary, change, left and right, if the same poll was taken multiple times. So we could do it over and over and over again. How accurate would it be? How much would it vary by? Would it say it went from 60% one day to 10% the next? That's a big vary, that's a big margin of error. Okay, so Americans' view of government's role. So people think the government is trying to do too many things that should be left to individuals and businesses. Others think the government should do more to solve our country's problems. Which comes closer to your own view? Well, let's look at this. We see this graph here. We have the green line is government is doing too much. So it starts down here and it gets higher, gets lower, higher, it kind of varies. And then you've got your light green line and you can see that it's low, up, spike here, and then going down low again. It's interesting enough, it happened here in this date. So the results for this Gallup poll are based on telephone interviews conducted September 7 through 11th in 2016 with a random sample of 1,020 adults aged 18 and older living in all 50 US states and the District of Columbia. The results based on the total sample of national adults, the margin of error sample is plus or minus 4 percentage points at the 95% confidence level, blah, 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 blah. And for the above example, write 2 absolute value equations for 2016 then state the margin of error may change the percentage of both people who believe the government is doing too much, people who believe the government should be doing more. So let's start with too much. Okay, so this is for 2016. So we're assuming this is going to be this date here. So what we're talking about here is your middle value is 54. Because it's got a sampling error of plus or minus 4 percentage points. So we're going to go up 4, we're going to go down 4. If I go up 4, 1, 2, 3, 4, that takes me to 58. If I go down 4, that takes me to 50. Oops. There we go. So it varies between 50 and 54. Remember, this is your middle, and 4 is your distance. So in terms of writing this, we've got the absolute value of x minus 54 equals 4. And then talking about wanting the government to do more, that would be the light green one, and that's at 41. That's got the same percentage or margin of error, plus or minus 4, so the middle value is 41. If you add 4 to that, you get to 45. If you subtract 4 from that, you get to 37. So your middle value is absolute value of x minus the middle value equals that distance of 4. And it's that basic. Alright, we are done.